All right, today we are going to start talking about graphing of the sine and cosine functions. And I have the unit circle here because it's going to help us with the shape of our graphs. So we're going to start off by graphing sine of x. So no transformations, our general basic sine of x graph. And this is going to be based upon the unit circle. We are going to end up graphing two cycles, which we'll talk about more in a second. Each cycle represents one trip around the circle. And when we label this, we're always going to label in radians. So one trip around our circle is going to be 2 pi. So our first cycle is going to start at 0, and we're going to go all the way to 2 pi. Just like our circle is broken up into 4 quadrants, we're going to break that up, our graph, into 4 pieces. So we see that at 90 degrees, we are at pi over 2, pi, and 3 pi over 2. This again is going to represent one cycle, one turn around our unit circle. The sine graph, in case you forgot, is the y coordinate. So if I'm at 0, what is the y value at 0? If I go to my unit circle, the y value at 0 is 0. That is my starting point. Now when I go to pi over 2, my y value at pi over 2 is all the way up at 1. So at pi over 2, my sine is 1. Now I go down to pi. When I'm at pi, my sine is back down to 0. And at 3 pi over 2, now my sine has moved down to a negative 1. And at 2 pi, full circle, we're back at a sine value of 0. So one trip around our circle, and this is our sine graph. Now I'm going to go 2 cycles. I'm also going to go the other direction. So one was clockwise, one is counterclockwise. So if I'm at a negative pi over 2, that's the same as 3 pi over 2, which gives me a sine value of a negative 1. If I go to a negative pi, now my sine value is back at 0. If I'm at negative 3 pi over 2, my sine value is up at 1. And full circle back at 0, which is a negative 2 pi. Here is my second cycle. So this is going to be the shape for every sine graph. In the sine graph, you always start at the middle of the wave. You go up, down, back up. Now we have our cosine graph. So we want to think about that the same way that we just did. Cosine, again, is the x value. So we're still doing one cycle around. So our 4 quadrants, starting at 0. So when I'm at 0, the cosine, the x value, is at 1. So our first point this time, instead of being at 0, 0, is going to be at 0, 1. When I go to pi over 2, my cosine value, the x, is at 0. When I go to pi, my cosine value is at a negative 1. At 3 pi over 2, my cosine, the x value, is back at 0. And at 2 pi, our cosine value is back at 1, full circle. So we see the shape of our cosine graph. That's one cycle. Again, we are going to do 2 trips around our circle, one positive, one negative. So at 0, now we're at a negative pi over 2. My cosine value is 0. At a negative pi, my cosine value is a negative 1. At negative 3 pi over 2, my cosine value, that x value, back at 0. And a negative 2 pi, my cosine value is back at a positive 1. And there is our cosine graph. So we notice that the sine graph is going to start at 0, 0, and it's the middle of the wave of the graph. The cosine graph is going to start at the peak of the wave. All right, we don't need the unit circle anymore. We're going to look closer at our graphs, the one thing that you want to make sure that you're doing, make sure you include the arrows. And we're going to talk more about how you should draw your arrows as we get our graphs to be more complicated. Under the terminology below, the domain of each function is going to be all real numbers. We know that the domain is the x's. We notice that both of our graphs are going to forever go left and forever going right. It's going to be this wave that keeps on bouncing up and down, up and down. So there's no restrictions on that domain. The x's are going to be everything. Now the range for both of our graphs, it stops at 1, bounces down to a -1, comes back to 1, back down to -1, up to 1 for both the sine and the cosine graph. So the range of your function is going to be from a -1 all the way to a +1. That's just for the general form. The graph has a repeating pattern that continues indefinitely. The shortest repeating portion is called a cycle. That is going to be one trip around your circle from 0 to 2 pi. The horizontal length of each cycle is called the period. So if we go back up to our graphs, from here to here is your period. That is 2 pi, and again, that's going to represent one cycle. This is also one cycle of your graph. Your period is 2 pi, the distance it takes for one complete cycle. And we talked about the fact that your range is from top to bottom, so you can see that your range here is between a -1 and a +1. Same thing for our cosine graph. We peak up at a +1 and a -1, so your range goes from a -1 to a +1. The period is your cycle, and again in this case the period is going to be 2 pi, which is the distance of one cycle, one turn around the circle. A little bit more terminology down here. The amplitude, this is going to be the absolute value of your A, which we'll get to. That is how tall is your wave going to be. What's the distance between each of the levels? So as you go from one point to the next, in this case, our amplitude is 1. Because from 0 to 1, 0 to -1, you're moving a distance of 1. Your amplitude is the distance between your levels. Your period, in this case it was 2 pi, but we're going to take 2 pi and we're going to divide it by the absolute value of b, which again we'll get to. The period is the distance it takes for one cycle. Each graph should have 5 key x values per cycle. So when you look at any of your graphs, here's 1, 2, 3, 4, 5. Now this point is used twice. 1, 2, 3, 4, 5. Your starting point is going to be part of both cycles. So it's going to be included in your positive and your negative. All right, go ahead and turn over. Now we have all of these transformations. So this is where your A and your B are going to come in. Here's your general forms. Today we're only going to be talking about vertical shifting and stretching. So your vertical shift is the shifting of your graph k units. So out here. And stretching is going to come from your A value, your amplitude. And when A is negative, you're going to reflect. So when we're looking out here, here's your A value. When we look at our first one, we see that our A value is 3. Your B value, there's no number there, so it's going to be 1. There's no H, there's no K. So remember that your period is 2 pi divided by B, which is 2 pi divided by 1, which just means it's going to be pi. So the length of one cycle is going to be all the way to 2 pi. Now remember, to find those tick marks, we broke it up into 4 pieces. So to find the interval, you take your period and you divide it into 4 equal pieces, which is how we're going to get pi over 2. The amplitude is your A value, and the vertical shift is how much you're moving up and down. That's the K. So we don't have a K value, so there's not going to be a vertical shift. Now I'm going to go ahead and set this up. We have our X values set up. We're going to go the same in the other direction. So a negative pi over 2, a negative pi, a negative 3 pi over 2, and a negative 2 pi. The general, I'm going to sketch the general sine graph so you can see how things are different. Now sine normally goes to a positive 1 and to a negative 1. So just a reminder, on the front page, that is the general shape of your sine graph. The most important thing to remember is that sine normally starts at 0, 0. And then it goes up to 1, back to 0, down to negative 1, back to 0. That is going to be one cycle of your sine graph. We go the other direction, we've got to bounce. Again, this is the exact same sine graph that we did on the first page. I'm doing a dotted graph of that because that's not the graph we're doing. We want the sine of 3x. What that 3x is going to, or what that A value of 3 is going to do is it's going to cause a stretching. We're stretching that graph out. We're stretching it out by a factor of 3. So instead of going from 0 to 1, I'm stretching it out to a value of 3. And then back down to 0. And then negative 2, negative 3, down to negative 3, and then back. So here's going to be the first cycle of y equals sine of 3x. Always circle your starting point. Very, very important. And we go down to negative 3, to 0, up to 3, back down to 0. Here's your second cycle of your sine graph. Now you have 3 levels to your graph, and we plot this with a dashed line. The highest our graph goes is a positive 3. The middle level is going to be at 0. And then the bottom level is going to be at a negative 3. So all of your points are going to fall on one of those levels. You go from 0 to 3 to 0 to negative 3 to 0, and the next point would be back up here. The amplitude is seen between each level. So going from 0 to 3, 0 to negative 3, there is a distance of 3 between each level. So that y equals 3 of x caused my graph to stretch out vertically by a factor of 3. Now our next graph is cosine. Notice that here our A value is back to 1. Our B value is still 1. There's still no H because we're going to talk about horizontal shifting later. Your K value is 2. We have not changed the period, which means it's still 2 pi, pi over 2. The amplitude is still 1. And that K equals 2, that's going to cause my graph to go up 2. We always start by getting our graph ready. So one cycle is 2 pi. So we're going pi over 2, pi, 3 pi over 2, 2 pi. Our other direction, negative 2 pi. Cutting all of those pieces in half, they are negatives. Now our amplitude is only 1, but we're going to start off by shifting our graph up 2. So I'm going to start just like the last one, and I'm going to sketch what the general cosine graph is without transformations. Remember, cosine starts up at a positive 1, down to 0, down to negative 1, up, down. So here is the general form of one cycle of a cosine graph, starting at the top of the wave, coming back down, what we're going to do now, the only change that we've made is that we're going to move that graph up 2. So the cosine graph that normally starts at 0, 1, I'm going to move it up 2 spots. So now my starting point is at 0, 3. I'm just going to take that entire graph and move everything up 2. Now my levels, cosine, when it's positive, it's going to start up at the top of that wave. The middle, because my amplitude is 1, is going to be 1 level below at 2. And then the bottom level is going to be 1 below that at 1. Again, because the amplitude is 1, there's going to be a distance of 1 between each of your levels. Now again, cosine starts up at 0, 3 because we shifted everything up 2. And then I follow that pattern until I hit the bottom of the wave, the middle, the top. It's going to go until it hits the bottom level, and then it's going to bounce back up and come back down. So when you draw the arrow, we're hitting the top of this. What you don't want to do is draw your arrow this way, because that's going to get you lost points. It's going to hit the top of that wave and it's going to come back down. So then it hits the bottom, bounces back up till we hit the top. So your second wave here is going to be over there. Again, your starting point, you want to circle your starting point, which is going to be at 0, 3. Last one. Got a lot more going on here. So we've got an a value of a -2, a b value of 1, no h, and a k value of 1. So the b value is what changes the period in the interval. So I'm not making any changes there. Your amplitude is 2. Because your a value was a -1, we have to reflect. As soon as I see that negative, I'm going to draw a little star and I'm going to remind myself to reflect. If I don't draw my little star, I may forget. And then that k value is going to tell me that I'm going to go up 1. The most important thing is to find your starting point. So we set up our tick marks. We always have to label. You have to label the x and the y-axis. When I'm going to find my starting point, I go in the order of my pieces. So I did the period, I did the interval, that's setting up my x-axis. I want to amplify my graph by a factor of 3. So sine normally starts at 0, 0, and I have a sine graph here. So if I'm at 0, 0 times 2 is 0. So I'm still at 0, and then I want to go up 1. So my starting point for this graph is going to be at 0, 1. Again, sine normally starts at 0. It has an amplifier of 2, so 0 times 2 still is at 0, and then I go up 1. It's important to remember about your sine graph. Your sine graph starts in the middle of the wave. So knowing the basic sine and cosine graph is going to be really important. So this is the middle. Because my amplitude is 2, my next level is going to be up at 3. Again, the amplitude means the distance between levels, and then below that at a -1. Because again, you want to have that consistent amplitude of 2 between each level. So your sine graph again starts in the middle. Normally sine goes up first, but because we are reflecting, it's going to go down, bounce off the bottom, come to the middle, to the top, that bounce back. So this is one cycle of my sine wave. I'm not going to go back down. This should be a mirrored image every single time. So I'm going to continue until I hit the top, middle, bottom, and then it bounces back up. You should see symmetrical waves all along the way. We should have, if I continued for 4 or 5 cycles, it should never break that pattern of bouncing from the bottom. It doesn't bounce till it hits the top and then back down. All right, so this was a long one, I know, but we are now done with vertical shifting and stretching.